Here are some common circuit components that you need to know. You also need to know the symbols that we use to represent them. In this video, I'm going to focus on these 5 here. This component here is a fuse and is represented using a rectangle with a line going through it. Let's look at how a fuse works. Let's say this is the inside of a 13 amp fuse. There's a thin wire right in the middle. If I put a 1 amp current through it, it's absolutely fine. It works completely normally. If I start to increase that current, let's say 9 amps, as you can see, it's starting to heat up there, but it's still working. Okay, then I put 12 amps, it's still working, but you can see it's getting a lot hotter and the wire is starting to heat up. But if I put a 14 amp current through it, then it's actually going to melt the center of the wire there, and it's going to stop, and the current is going to stop flowing. So basically, a fuse contains a thin wire which heats up and melts if the current is too large. So for a 13 amp fuse, if you go anything above 13 amps, is going to melt the wire in the center. And this will stop the large current from flowing, or any current after it's gone beyond 13 amps. And so it prevents damage to the circuit. It prevents shocks as well to any people who are using the circuit. This component here is a diode. It's represented using a symbol that looks like this. I like to think of it as a circle with an arrow pointing towards the right like this, and a wall on this side. Okay, so what does it do? So let's connect it to a circuit first. So in a circuit like this, we've got the positive and negative ends of the cell, and current is going to go from positive to negative. When it goes through the diode, as long as the current is flowing in the direction of the arrow, it's okay, it will work. And so in this case, the current will flow and the bulb will glow. Okay, so it allows current to flow in the forward direction. However, if I connect the other way around, so let me flip the diode around. Now, if I connect it this way, the current is still flowing from positive to negative, or is trying to anyway. But because the arrow is pointing the other direction, it will not let the current flow. So basically, a diode has very high resistance when connected in the reverse direction, and it would not let the current flow in the reverse direction. So always look, trace the current from the positive to the negative and check if the current is flowing in the direction of the arrow. If not, the current will not flow. Think of it as it's almost hitting the wall, and then the current can't flow anywhere in the circuit. So this component is an LED. LED stands for light emitting diode. So basically it's a diode, but also emits light when it's conducting. So the symbol is the same as a diode, except there's two arrows pointing away to represent the light that's going to be emitted when it's conducting. Okay, let's connect it to a circuit. Now in a circuit, the current flows from positive to negative. So in this case, the current is trying to go through the diode going towards the left, and the arrow in the diode is pointing towards the left, so it will conduct and the LED will glow red. Of course, you could have different color LEDs as well, but this one here is red. Okay, so allows current to flow in the forward direction and glows when it does so. But now let's connect it the other way around. Now instead of turning the diode around, I'm going to turn the battery around, or the cell around. Okay, so now I've connected this way, and the current is going to try to go towards the right now, from positive to negative. But as you can see, the arrow inside the diode is pointing towards the left, so that means there will be no current flowing at all, because the resistance is going to be very high when it's trying to flow in the wrong direction. This component here is a thermistor. It is represented using a rectangle with a tick going across it like this. So basically, its resistance depends on its temperature. So as temperature increases, the resistance decreases. This is strange because normally for metals, the higher the temperature, the higher the resistance. But this is not made from a normal metal. Okay, so it's used in temperature sensors. That's where it's very useful. So let me give you an example. So over here, we've got a thermistor connected with a fan. And let's say it gets really hot in this room and the temperature increases. The resistance of the thermistor is going to decrease. That means if there's low resistance, there's going to be more current in the circuit. Also, because the thermistor's resistance is lower, more of the voltage is going to go to the fan. So the fan's getting more voltage and more current, so that means the fan is going to turn on. So basically, overall, as the temperature increased, the fan turned on. As you can imagine, this is very useful, especially when you want to cool the room down, not let it get too hot. So it's useful in temperature sensors like this, in thermostats, computer fans like the one I just showed you, car engines, and so on. Okay, so this component here is an LDR. That stands for light dependent resistor. So as the name suggests, its resistance depends on the light that's shining on it. Okay, so the symbol is a rectangle with a circle around it, and these two arrows represent the light that's going towards it. Okay, as light intensity on the LDR increases, the resistance is going to decrease. So if I shine light on the LDR, its resistance goes down. So that means it's very useful as a light sensor. So let me give you an example. So here I've got an LDR connected to some alarm like this. If I shine light on the LDR, its resistance is going to decrease. Okay, so that means less resistance in the circuit, so the current in the circuit is going to go up, it's going to increase. And also the alarm is going to get more voltage because the LDR is getting less voltage because it has less resistance. So this means that the alarm is going to turn on because it's getting more current and more voltage, so it's going to sound the alarm. So what we've done is, as we increase light, we've made the alarm sound. So as you can imagine, this might be useful as a morning alarm when it gets bright and you want the alarm to turn on. But there's many other uses. You can use it in automatic street lights, light meters and cameras, and alarm systems, and many other ways as a light sensor.